Hi everyone, Titus here for another Unreal Engine tutorial, and today we are continuing to explore the AI framework by looking at the AI perception system. This system provides sensory data for your AI agents to use, including sight, sound, and even touch. Let's not waste any time and jump right into it. Alright, so I got a demo little drone here. We're going to use this to configure some of the AI perception systems. To get started, let's first open up the enemy controller class, which we got right here. And then what we're going to do is you can add your AI perception to your pawn or your controller. For me, it makes more sense to do it in the controller. We're going to hit add, and then we'll search for AI perception. And then once you have that selected, in the details panel on the right, you can actually add one of the senses. You just hit the little plus sign here. And then for the index, you can drop down and do hearing, or on damage, prediction, sight, touch, all sorts of stuff here. In this example, I'm going to use just the general sight. I'm going to expand out that sense, and we got some additional options here. One thing I will want to set is the detection by affiliation. By default, everything is set to neutral, so I'm actually going to focus on neutrals for now. But if you were doing like some sort of team setup, you can set up like enemies and friendlies and then target them specifically that way. And then we're going to play with the max age. Currently it's set for infinity. I'm going to set that to be maybe 10 seconds. And then we will compile and save this. The last thing we'll need to do is we'll need to open up our pawn. And I have a blueprint here that's represents my pawn. With the pawn selected, I can go to my details panel and actually just search for pawn. And then we're looking for the AI controller class. Currently it's set to AI controller. I'm going to set it to my custom controller that I set up, which is BP enemy controller. And then if I compile and save, we can now actually play the system. Nothing's going to happen, but if I hit the apostrophe, it'll enter in the little debug mode. And then I can press, looks like it's going to be number 4 for perception. And we can kind of see what the system's doing. Now if I enter the range, you see it adds a little debug sphere over me. That means I'm in its target range, which I think it was set to like 90 degrees on the half angle. And then if I go in front of something, you see there's a little age thing that's actually showing when that reaches 10 seconds, that little debug sphere should actually go away. And then if it sees me again, it'll basically redraw the sphere. And this is essentially how the iSenses system is working. So currently it's using a visual cone for sight. And then we're basically going to kind of code off this. So let's actually get the drone moving around. To be able to do that, we need to kind of make use of the navigation system. So I did add a nav mesh bounds volume. So if I select that and press P, you can see there is navigation data loading into the map. So I can make use of that using a behavior tree. So let's actually go to our folder. We're going to create our first artificial intelligence blackboard. We'll call BB_drone. And then we got to right click, go back to artificial intelligence, and we will select behavior tree. We'll call this BT_enemy. And if we double click this, you'll see that the blackboard asset looks like it loads by default. If it doesn't, just select it in the list here. And then you can switch between the blackboard and the behavior tree in the top right corner here. Starting off, we'll pull off our root and we'll add a selector. The selector we're going to rename to be the trunk. And then we will pull into 3 sequences. The first sequence we can call chase. And then the second sequence we will call maybe investigate. And then the last sequence we will call loiter. Now, if you're new to behavior trees, I do have some other videos that are specific to them, so you can learn more about them, but effectively they the execute top down, left to right, and you can see there's little numbers on each of the nodes. So this one's first, this one's second, third, and then fourth. All right, but we're gonna basically just code a basic tree. So for my chase, I'll do a simple move to, and then the investigate, I will also do a move to, and then for the loiter, I'm just gonna use a basic wait. And then I'll set the wait time to be 1 second. Now for the move to actions, we need to set up some sort of target, some sort of vector. You can do a vector location, or you can do like an object in the world. But to be able to control that, we need some Blackboard keys. So we'll select the Blackboard in top right corner, and we can create some new keys here. The first one I'm going to do is going to be a vector, and we'll call this the target location or target lock. And then the next one is going to be an object that I'm going to call the player. And then I'm going to select the player, and in the key type for the base class, I'm going to switch it from an object to be an actor. And then I'm going to add a couple booleans. The first boolean check I'll do is alerted. And then the next one I'll do is investigate. Oops. Investigate, there we go. And this should pretty much complete all the Blackboard keys that we're going to be using for this demonstration. So we can go back to our behavior tree here. So for the chase sequence, what I want to do is I want to set that Blackboard key to be the player. And then for the investigation sequence, I want that Blackboard key to be the target location. And then the way I can control entering in these states is we can use those Boolean checks. So if I right click on the sequence node, we can add a decorator, and the decorator we can use is Blackboard. It'll add this conditional check. If I just highlight it, I can then set the Blackboard key. In this case, I'm going to say this one's alerted. For the observer aborts, I'm going to actually set this one to be both. And again, if you need more clarity on that, I do have another video that basically touches specifically on just Blackboards. But basically what that means is when this condition's flipped, it'll pull the AI out of whatever branch it's in, and it'll recheck everything from scratch. And that just basically means it gets in the state a little bit quicker when it sees the player. And then for the investigate, make sure, yeah, we got that set. Okay, so for the investigate, we will add a decorator as well for Blackboard. And this one is going to be investigate. And then I'm gonna actually rename these. I can say maybe investigate. Probably should have came up with a better name. And then this one, I will say maybe scene. Maybe I should rename this one to lost. Yeah, I think that maybe that makes more sense. Okay, so we have the basics of our behavior tree set up. Now what we can do is we can actually begin to code out some of the logic for this. Because right now, if I were to play the thing, nothing's gonna happen, and you can see that there's no behavior tree in the top left corner. Nothing's actually happening. So if we go into the actual enemy controller, and then we can go to our override, and then the function we can use is onPossess. We can pull into a run behavior tree. And the behavior tree we're going to do is the only one we created, which is the BT_enemy. Now from there, we can select the AI perception in the components tree, and then you can right click and you can see functions and events related to perception. I'm going to expand out the events and the event dispatchers, and you can see I have a few here. The one we want is the on target perception updated. So it'd be this one right here. This one's a little bit basic. It just has the actor and the stimulus, which is pretty much all we need for a good chunk of this code. What I want to do is I can pull off this into a control branch, and then I can break this stimulus, and there's a successfully sensed node here. If we pull into a print string and we pass this in here, we can maybe see what this is doing really quickly. So we will go ahead and go into perception, and you can see, actually I probably need to get rid of that. You see false true is coming up, false true, false true. Basically what's happening is anytime the sphere gets created and it's on me, it's true. If it gets basically lost like that, it gets set to false. So we can see when the drone is actually losing sight of the player. Where that would become pertinent is we can control behavior like where the drone chases the player versus where the drone investigates the last known position of the player, that sort of thing. So let's go ahead and shift delete that. We will add the stimulus in here like so. And then effectively what we want to do is we want to set the Blackboard values depending on, well, we're going to set them no matter what when this gets kicked off, because this is only going to be sensing the neutral players in the scene, which I only have me at the moment. So we can right click and search for Blackboard. Scroll down the bottom, there is a get Blackboard little node here. And then for this one, we can pull a set value as Boolean. And then on the true pin, we'll pull into here. And we're going to set this to true. And now I just need to set the key name. So we can pull this and do make literal name. And then we just need to write in the key name that we want to update. So if we go back to our keys, this one's going to be the alerted with a question mark. So this one right here. So I can copy that, and we can just paste that in there. And basically when it sees me and it's marked true, we will set that Blackboard value to true. And then the other thing we'll want to do is we'll want to set the object to actually track. So we can select the Blackboard here, duplicate it over on this side, and then we can do set value as, and there's an object one. So we can select that here, and then we just need to pass in the object reference and the key name. So we'll do the same thing we did with the other key. We could just make a literal name. And this one, I believe we called it player, but it would be, yeah, player with a capital P. So we'll just manually type that in here. And then for the object, we can actually just use the actor node on the sense pin. Pass this in over here. And that'll work just fine. So now we just need to handle the false section of this. So what we can do is set the target location. And the way we do that is, again, we'll just take the Blackboard, duplicate it, and then we can set value as vector. And then again, this key name, we can do make literal. And this Blackboard key was going to be target lock, short for target location. So, and then to get the location, we have a stimulus location and stimulus receiver location. The stimulus receiver location is the drone. The stimulus location is the thing the drone sees that triggers this. So in this case, it'd be the player. So that's the one I want. So I'll pass that in over here. And then basically what we have with this set of code is we have a way for us to enter in the scene section of this. And we technically have a way to enter in the loss section, but we are not unsetting the scene node. So I think we're going to get stuck in this one, but let's go ahead and take a look and see what this is doing. So we will go into our debug mode with comma, And you can see the Blackboard assets in the top middle. So alerted's false, investigate's false, player's none. So now if I come in front, you can see the drone starts following me, and alerted is true, investigate is false, and it's got me as the player, it has itself, and then it even has a target location, which was null before. And that's because I broke line of sight, and you can see I broke line of sight there. So it was 681 in the X value. If I break line of sight again, it'll change to negative 10,000, and it should lose me, but it's not going to, because I never leave the chase state. So the drone is basically always going to follow me. So we kind of need to solve for that. And the way we can do that is we go back into the enemy controller. We're going to use a different node. So right now we are entering in this state, but we're never exiting. So we need a way to kick off so we can get into some of these other states. So if we select the AI perception, we can right click, expand out the events. And there's another one here called on target perception forgotten. Oops, this one right here. And this one's perfect because what it means is if I go back to the AI perception, you'll notice there's a max age. We set it to 10 seconds. We set that to a lower value, like 2 seconds. When the AI loses like sight of me and that sphere kicks off, that's basically gonna should execute this code here, but there's gonna be a problem with it. Let's go ahead and select a Blackboard and duplicate this over here. Actually, I should have duplicated the whole thing, but what we can do is set value as bool, and then we're gonna pull off and do a make literal. And this one's going to be the alerted boolean we created. And instead of true, we'll set that to false. And then what we can do is just duplicate this. And then instead of alerted, I believe our other one was investigate. Let's double check that. Investigate, this one right here. So we're going to set that one to true. So we're basically flipping the keys. So this will be flipped to false. And because I have this set to both, it'll abort this sequence and it'll re-kick off the evaluation. So it'll check this again, which will evaluate to false. It'll move to this one, and this one should evaluate to true, which means this thing should move to the last target location, which is this Blackboard key here. And we know this was actually already being populated, so we should be able to see something happening with that. But there is an issue with this. So if we compile and save, I will bring up our debug window, and we can see the investigate's false. Let's get it to true. So we'll come over here. Alerted is true, investigate's false. I'll jump off this little platform here. I just have to lose it for 2 seconds. You see, investigate is now going to turn, or should turn to true, but you notice it's not, even though I did technically lose it. And let's just make sure that I am correct with that. We will go back into perception, and we can see the spheres around me. See how it lost the sphere, and it reached the 2 seconds, and the sphere is gone. It cannot see me, but it knows I'm here, and that's because those keys are not getting cleared. So I don't know why Unreal has this, but this setting does nothing unless you go to your project settings and look for under engine, I think it's AI system. There's a forget stale actors. You have to check that. So I don't know why they put it there, but once you check that, if you go back in, and now we can bring up our debug window here, get rid of that. So we got the sphere on us. Let's go ahead and try that same logic and see what happens. Jump over, loses sight. Now you notice the investigate set to true. It's not tracking me, it's just going to my last known position. And now it's moving into the loiter phase. Which if I get rid of 4, Actually, no, I lied. It's still stuck in investigate. So it's never leaving investigate right now. So we got to figure out how to pull it out of investigate so it can move to loiter and maybe change up the behavior a little bit. But if I re-enter its line of sight, it'll trigger again. So that part is still working. Okay, but let's go ahead and add some additional functionality. So right now we're able to get out of the chase sequence and we go into the investigate sequence. Now we just need a way to kick out of the investigate sequence and move into the loiter sequence. And the way we can do that is we can use a custom task here. So what we'll do is at the top, you have predefined Blackboard tasks that you can run, or you can create a custom task. So we'll call this maybe behavior tree task underscore spin, something simple. And now when I go over, I pull to the right, I got the BTT spin right there. And remember, these execute left to right? So this one goes first and then this one. So we'll have it move to the location that it last saw the player, and then we'll just have it do a little spin, and then I'll reset the Blackboard keys so I can then go into loiter. All right, so for the function overrides, we can add a receive execute AI, and then we can cast to the enemy pawn, which in my project is called BP underscore enemy. And then I can just pass the controlled pawn into the object field here. And then in my enemy, I have a custom event just called spin. It just uses a timeline, and then it adds or sets a relative rotation based on 2 seconds. It basically just spins on the Z axis. Very, very simple. So nothing too crazy here. So what I can do is after I cast the enemy, I can call spin, and then it's going to spin the little drone. If it fails, if the cast fails for some reason, I still want to call finish execute and set the success to false. Because when you're setting up custom behavior tree tasks, you need to set up a way for it to succeed and for a way for it to fail. Because if you don't, you get stuck in the task forever and you cannot reevaluate the rest of the tree. So there needs to be a graceful exit, either success or failure. So you need to account for both. So this will be my failure, and now I can set the rest of the code and then call the success. So for this one, I'm going to wait maybe 3 seconds. So after 3 seconds, I will then set Blackboard value as, we'll do Boolean. And I'm going to set the value to be false, but you'll notice the key is different. The key's blue and it's not green. I can't make a literal on this, but what I can do is I can just right click, promote this to a variable, and then I can just call this my key reference. And if you set this variable to be public, so just by clicking the eyeball or checking instance editable on the right, and you compile that, if we go back to the behavior tree, and I select that custom task that's in, you see how I have my key reference there. I can then pass in the Blackboard key that I want to update or that I want to write to. And remember, this one we want to get rid of the investigate. So this is this one's the alert, this one's the investigate. So we're basically going to be overwriting this Blackboard value. So I'm going to set that Blackboard value to false, and then I can call my finish execute. And then this one's going to be my true. So now I have a false exit and I have a true exit. So this custom behavior tree task is good to go. So now let's go ahead and head over here and let's see. Click apostrophe, go into my debug menu, get rid of one, click 1 to get rid of that. And then I'm going to do, I will do my nav mesh so you guys can see that, and I will do my perception system. Why not? We'll do those. Okay, so we see the angles like 180 degrees that it can see. So I'll come over here, it sees me, and then it's basically chasing. Remember, it's a 2-second expiration for it to lose line of sight. It's using the nav mesh to calculate its trajectory. And now it's investigating the last known position. It does a little spin, and then it loiters. And if I get rid of some of these other things right here, so let's get rid of the nav mesh. Let's get rid of EQS perception. And then you can see the behavior tree on the top left corner right now. It's in loiter. So it's in the loiter sequence. And then if I come back, it sees me again. It goes back into the chase sequence. And then it's basically just going to chase me around like so. All right, good people, I think we'll cut it here, but I hope you found some informative value in this topic that you can take into your own projects. But as always, thanks for watching, consider subscribing, and we'll see you on the next one.